Deep beneath the icy surfaces of Antarctica and Greenland, hidden from the world above, lie mysterious bodies of water known as subglacial lakes. These hidden lakes, locked away under miles of ice, are more than just frozen curiosities. They are time capsules, scientific treasure troves, and windows into Earth's distant past. Today, we're diving into the fascinating world of subglacial lakes, exploring what they are, how they form, and why they might hold the key to unlocking some of Earth's most profound secrets. Imagine a landscape so cold and remote that it feels like another planet. Antarctica, a continent covered in ice sheets up to 2.5 miles thick, is home to over 400 known subglacial lakes. These aren't your typical lakes with sandy shores and sunlight dancing on the surface. Subglacial lakes exist in total darkness, sealed beneath immense pressure and insulated by the ice above. Some, like Lake Vostok, are massive, larger than Lake Ontario, while others are small, fleeting pools. But what makes these lakes so special? To understand that, we need to start with how they form. Subglacial lakes are created by a delicate balance of heat, pressure, and ice. Deep beneath the ice sheets, geothermal heat from Earth's core slowly warms the base of the ice. This heat, combined with the immense pressure of the overlying ice, lowers the melting point of the ice, allowing liquid water to form. The ice above acts like a blanket, trapping this water in pockets where it can remain liquid for millions of years. Some lakes are stable, existing for eons, while others are dynamic, filling and draining in cycles as the ice shifts. These hidden waters are like secret worlds, isolated from the atmosphere and untouched by modern life. One of the most famous subglacial lakes is Lake Vostok, buried beneath nearly 2.5 miles of Antarctic ice. Discovered in the 1990s, it's one of the largest subglacial lakes, stretching 150 miles long and holding water that's been sealed off for up to 25 million years. To put that in perspective, when Lake Vostok was last in contact with the outside world, Antarctica was home to forests, and early mammals were just beginning to roam the Earth. This isolation makes subglacial lakes like Vostok potential gold mines for understanding ancient climates, geological processes, and even the possibility of life in extreme environments. But studying these lakes isn't easy. Drilling through miles of ice to reach them risks contamination, which could destroy the very secrets scientists hope to uncover. To solve this, researchers have developed ingenious methods. They use radar and seismic imaging to map the lakes from above, detecting the flat, reflective surfaces of water beneath the ice. For Lake Vostok, Russian scientists spent decades drilling with extreme care, using sterile techniques to finally reach the lake in 2012. What they found was astonishing. Water samples revealed traces of microbial DNA, suggesting that life might exist in this dark, high-pressure world. This discovery raises a tantalizing question. Could subglacial lakes be home to unique ecosystems? The water in these lakes is often rich in dissolved minerals, and some scientists believe microbes could survive by feeding on chemical energy, much like deep-sea vent communities. If life exists in subglacial lakes, it could reshape our understanding of where life can thrive, not just on Earth, but on icy moons like Europa, a moon of Jupiter with its own subsurface ocean. Subglacial lakes are like natural laboratories offering clues about life's resilience in the most extreme conditions. Beyond biology, subglacial lakes hold secrets about Earth's climate history. The water and sediment in these lakes act like archives, preserving records of ancient atmospheres and temperatures. By analyzing samples, scientists can reconstruct what Earth was like millions of years ago. For example, sediment cores from Lake Vostok could reveal how Antarctica transitioned from a lush, green continent to the frozen desert it is today. This information is critical for understanding how ice sheets respond to climate change, which is vital as global temperatures rise and polar ice melts. Subglacial lakes also play a surprising role in the movement of ice sheets. Some lakes, known as active lakes, periodically fill and drain, causing the ice above to shift. This movement can accelerate ice flow toward the ocean, contributing to sea level rise. By studying these lakes, scientists can better predict how ice sheets will behave in a warming world, helping us prepare for the impacts of climate change on coastal communities. But the study of subglacial lakes isn't just about Earth. These hidden waters are helping scientists prepare for missions to other worlds. Europa, with its icy crust and subsurface ocean, is a prime target for astrobiology. The techniques used to study subglacial lakes, like remote sensing and clean drilling, are being adapted for future space missions. If we can learn to explore Earth's subglacial lakes without contaminating them, we might one day do the same on Europa, searching for signs of extraterrestrial life. As technology advances, our ability to explore these hidden lakes improves. New tools like autonomous underwater vehicles are being developed to navigate the dark, high-pressure waters of subglacial lakes. These robots could collect samples and map lake beds without human intervention, opening new frontiers in exploration. Meanwhile, international teams are collaborating to ensure that any exploration is done responsibly, preserving these pristine environments for future study. Subglacial lakes are more than just scientific curiosities. They're a reminder of how much of our planet remains unexplored. They challenge our assumptions about where life can exist, how climates evolve, and how our planet's systems interact. As we unlock the secrets of these hidden waters, we're not just learning about Earth's past, we're gaining insights into its future and the possibility of life beyond our world. The next time you think of a lake, imagine one not under the sun but beneath miles of ice, waiting silently to share its ancient stories with those bold enough to listen.